Hello, Precalculus students. This is lesson 54, and this is the second part. And you should have your trigonometric identity paper that you filled out from part A finished and complete and ready to go here as we work through these. That was kind of the point of yesterday's lesson, was to get you ready for today's lesson. So make sure you have that paper so you can reference as we go through. And today you're getting a worksheet as well, and I'm doing some of these off your worksheet. So the first set there says use identities to find the value of each expression. I'm actually going to do 3 first because it's actually a little bit simpler than 1. So we remember for this from yesterday's that if I have sine of a 90 degrees minus x, that's the same thing as cosine of x. Well, I'm also remembering here that pi over 2 radians is the same thing as 90 degrees. So this is saying the same thing as this. So what is cosine of theta? Well, cosine of theta is just simply equal to that, negative 0.09. That's not too bad. Let's look at number 1. Number 1 is very similar, because remember this, right? 90 minus x is equal to tangent, and it's looking for tangent. However, this is 90 minus x, and this is x minus 90, essentially. So let's see if we can change this to look like this so we can apply this rule. Now, I could rewrite this as theta minus negative theta plus pi over 2 times the negative 1, right? I factored out negative 1, because if I said negative 1 times theta, it'd give me just theta. And negative 1 times this negative 1 times a positive pi over 2 would give you that negative pi over 2. Which means then that I could rewrite this then as negative 1 times pi over 2 minus theta. So now I can rewrite this as cotangent of negative pi over 2 minus theta. And I'm going to remember that cotangents are odd functions, so that means this is the same thing as negative cotangent of pi over 2 minus theta. Alright, and that's this rule here. And pull that negative outside. So now this part right here is going to be the same thing as tangent. So this would equal to negative tangent of theta. And this part right here is negative 4.7. So that means tangent of theta is just going to equal to 4.7. So essentially there I just changed signs. Alright, now the next section here is just to verify identities. So we're going to use identities that we've already learned yesterday to verify this. And what it means to verify is it means I need to work with just one side, generally the left-hand side, to make it look like the right-hand side. So I'm going to work on this hand side, the left-hand side, to change it to look like that. And I'm just going to show my steps so I can verify, kind of like a proof, that those two sides are actually the same. So the first thing I'm going to remember is that secant of x is equal to 1 over cosine. So I'll go ahead and just write that over here. Secant of x is equal to 1 over cosine of x. So that means this is going to be 1 squared over cosine squared of x times sine squared of x. If you want to think of it over 1. Well, and then if you multiply those together, this is going to be sine squared of x over cosine squared of x. And then I remember that tangent of x is the same thing as sine of x over cosine of x. So that means essentially the same thing, except there's two of them, right? So now it's going to be tangent squared of x is equal to tangent squared of x. And there, I am complete. Put a little box to verify you're done. Alright. Let's try another one. A trick that you can use for these is that sometimes it's just easier to change everything into sines and cosines. And then you can simplify it down, kind of as a way to break that down. It's kind of like writing it in prime factorization or something. So that's what I'm going to do here on number 8, is write this all in terms of sines and cosines. So cosecant, remember, is the same thing as 1 over sine of x. And this is going to be 1 plus 1 over sine of x. Now I have two different terms there on the bottom, so I'm going to try to add those together. In order to do that, I need to have the same denominator, so I'm going to multiply this 1 by sine of x over sine of x. I'm going to end up with 1 over sine of x over sine of x plus 1 over sine of x. Because this is sine of x over sine of x, so same denominator, so I say sine of x plus 1, that's the numerator. Denominator just stays as sine of x. Okay, then we'll multiply. You can ask an Algebra 2 student about this if you want to get rid of this. Multiply by the reciprocal of the bottom over the reciprocal of the bottom, so this is going to be sine of x over sine of x plus 1, all divided by sine of x over sine of x plus 1. So notice this is just a reciprocal of that. And since it's this over itself, this whole thing right here is just a big 1. Okay, so I'm not changing any values. So then, notice the top would multiply this sign, would reduce with that sign. And the numerator would just come out to be 1 over sine of x plus 1. All divided by, well, this reduces with that, and this piece reduces with that piece, so over 1. Or essentially, this is just 1 over sine of x plus 1, which you could flip-flop, which is the same thing as 1 over 1 plus sine of x, because addition is commutative. So there I have completed that informal proof. Let's do one more here. Let's do one more. We're going to use the fact that we remember that cotangent of x is the same thing as 1 over tangent of x. And so we're going to write this left-hand side as secant squared of x over 1 over tangent squared of x. Now I don't want a fraction with a fraction, so I'm going to multiply by the reciprocal of the denominator. Tangent squared of x over 1 divided by tangent squared of x over 1. If you also want to think about this as being over 1, you could do that. On my denominator, this tangent squared of x reduces with that one. This one reduces with that one, so everything on the bottom just becomes 1. And on top, I have secant squared of x times tangent squared of x over 1. It's really just everything divided by 1, everything divided by 1. That's the same thing as secant squared of x tangent squared of x. Okay, now I need to remember that secant of x is the same thing as 1 over cosine. of x. So now I'm going to replace this piece with that piece, essentially. So I'm going to say 1 over cosine squared of x times tangent squared of x over 1 if you want, gives you tangent squared of x over cosine squared of x. Notice that's what we started with, so I have completed my proof. Now you might ask, oh my goodness, how did you come up with which one to use? How do you know which one to use? And to be completely honest, it's just kind of trial and error. The more you practice, the more you'll figure it out. The trick is to try something, see if you can get it to work. If it doesn't work, try something else. So one of the main tricks would be to maybe break it down into terms of sine and cosine, like we did there on number 8. It's one of the main tricks. And if you get stuck, don't know what to do, feel free to text me, and I will see about seeing if I can give you a hint or be like, hey, try this one. Because honestly, it just comes with a lot of practice, and it will become easier and easier the more that you do that. So good luck with that. Your homework is a worksheet. You at least got 3 of them right.